minimum point, which we can see here, its root at the point x equals 0. It's going to have its minimum point at the point x equals to b. And this is the way it goes. Still the same graph, we're only going to shift it to this point. And this is x minus b all squared. What if we had x plus b all squared? If you had y equals to x plus b all squared, it means that it's going to be shifted to the left. So this will look like that. I don't know if it's going to cross there. I don't know at what point it's going to cross, but at some point it will cross the y-axis. But then it's the same graph of y equals x squared, but shifted to the minus b point. Remember, that's only a right or a left shift, depending on whether b is positive or negative in this case. Now, what about when you have y equals to, what about when you have y equals to x squared plus c? Let's see the effect of this c in the completing the square problem. Do you realize that y equals x squared plus c is the same thing as y minus c equal to x squared? So just like the problem when it was x minus b, if you have this to be y equals x squared, then y minus c equals x squared is the same kind of curve, but this one jumps up by plus c. So if this is plus c, instead of coming from the bottom, it goes just here and jumps up again. Do you understand? What about if you have y plus c, or let me say y equals to x squared minus c, or y plus c equals x squared? How will this curve go? The same situation, but crosses at the point minus c. Okay. Oh no, sorry. This is not going to be an N shape. It's still going to be U shape because the coefficient of x squared is still positive. Sorry, this is a mistake. It's still going to be a U shape, but it's going to touch it at minus c. Or anyway, I'm sure you understand what I was trying to draw anyway. So it crosses it at minus c point, but still the same shape. So when you've got c to be positive, it is shifted upwards, and when you have c to be negative, it is shifted downwards. So this one, which I was trying to draw there, is going to be like this at the point minus c, but still the same shape. So what happens when you have y equals to x squared? Oh wait, sorry. What happens when you have... All right, now let's combine the lessons of these shiftings. And by the way, instead of calling it shifting, we call it translation. So what happens when you have y equals to x minus b all squared plus c, which in actual fact is y minus c equals to x minus b all squared. All right, if this is the graph for y equals to x squared, then the graph of y equals to x minus b all squared plus c, which like we said is y minus c equals to x minus b all squared, is going to be shifted to the right by b and shifted up by c. So it's going to be shifted to the right and shifted up. So as you would expect, it should have shifted to the right and then up. So it goes to the right and goes up. So it's going to have its new minimum point here, but still the same shape as y equals to x squared, but shifted to the right by plus b and shifted to the top